Hello, hello, and welcome everyone. Good evening. I'm Dr. Hyde, and I'm here today with a whole host of fabulous people to celebrate the 1 year anniversary of the installation of the 1 meter telescope. As you may be able to see, we actually have two fabulous guests today joining us. And today's amazing guests are Professor Paul Delaney and Dr. Allan I. Carswell. We also have joining us today Gagan, Sana, and Gianluigi, our York University students, and we will be celebrating the anniversary of the installation of the 1 meter telescope and of course having a darn good time. And now we are here at the Dr. Allan I. Carswell Observatory with Dr. Allan I. Carswell and our own Professor Paul Delaney. We hope you enjoy this presentation, and of course, just as a reminder, we are broadcasting tonight live from the Allan I. Carswell Observatory, where Professor Delaney is actually located at the moment inside the observatory observation room. Just a little reminder starting off, York YouTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time here on YouTube, so make sure to tune in. Now, this event is celebrating a very meritorious and amazing event, and that is the arrival of the 1 meter telescope at the observatory on York University campus. Now, this telescope came in to the well-deserved fanfare, and it all came about back in 2017. Dr. Carswell donated $500,000 matched by York U to help purchase this fabulous telescope, which is a plane wave PW1000, in case anyone was wondering, 1 meter telescope. Now, the York Observatory was renamed to the Allan I. Carswell Astronomical Observatory to honor this donation, and we're going to talk a bit about this fabulous new telescope here today. Now, this telescope does have a much larger collecting area than any of our other telescopes. It is, in fact, our pride and joy, and is the largest telescope on any Canadian campus. It is currently set up for both photometry and imaging with spectroscopic capabilities coming soon. Now, we'll have a bit more about our guests, and later on, we'll go ahead and cover that bonzer beaut of a telescope. First of all, I'd just like to say a few words about Dr. Allan I. Carswell, who is here with us tonight. Now, of course, I am not going to be able to cover everything because Dr. Carswell has done an amazing amount of things, which it does not fit on this slide at all. But just a few highlights, I suppose. Dr. Carswell graduated in 1960 from the University of Toronto with a BAsC in engineering physics and a PhD in physics, and actually went over to the Netherlands for a short time with the University of Amsterdam, one of my own favorite spots personally. So great trip. Sounds like it was well engineered, as it then led to him going on to RCA laboratories in Montreal and doing amazing things with lasers. In fact, the very first lasers had just been invented around that time. And this led to all kinds of amazing laser research, which we will talk more about with some of our questions. And of course, this was, just so you know, some of the first helium, neon, and carbon dioxide lasers in Canada. And we could probably spend this entire show just talking about the lasers, but we won't quite have a chance to. Dr. Carswell did, of course, then go on to join the faculty at York University, and we'll ask him a little bit about that later on in our show. We also will be talking a bit about his contributions to the planet Mars, which is also one of my favorite planets. So I am very much looking forward to that part of our show. Now, in 1974, Dr. Carswell, along with his wife Helen, founded Optech Incorporated. So it's a bit of an entrepreneur as well as all kinds of other amazing things. And this Optech Incorporated developed LiDAR systems and applications using advanced electro-optical technology. This then did all kinds of amazing things, leading from airborne surveys, 3D imaging, atmospheric measurements, and lots of other things that would be very valuable for space systems, as you'll find out when we get to Mars. So Optech was eventually sold, and Dr. Carswell was the recipient of many awards and accolades along the way as this was going on, as he was also still a professor at York. So very, very good at multitasking, Dr. Carswell. And he then went on to participate in, of course, several different Canadian institutions, which we will not have time to go through all of them, unfortunately. But we'll talk a little bit more about some of his contributions and activities at York. But he was also the president of the Canadian Association for Physicists, vice president of Canadian Academy of Science, and as many different positions throughout physics and astronomy in Canada. He is the founder and president of the Carswell Family Foundation, which, as you will see later on, was a very important part to us getting this 1 meter telescope. And as an author, researcher, engineer, and entrepreneur, Dr. Carswell, it is really wonderful having you here tonight. Thank you so much for joining us.
Well, it's a pleasure. It's a pleasure for me to be here and welcome everybody for this very special occasion. And looking forward to all the new information that's coming out.
Wonderful. And yes, thank you for hopping in and saying hello. I will just keep going here because we have so many fun and fabulous things to get to. We do also have Professor Paul Delaney joining us live, truly live from the 1 meter telescope. And of course, Paul Delaney, as Professor Delaney was, much like Dr. Carswell, it is very difficult to cover everything he has done in one slide. So we will not even try. I'm just going to touch on a few highlights. Professor Delaney was born in South Australia and received his Bachelor of Science degree from the Australian National University in Canberra. No matter how long I searched on Google, I was not able to find pictures of him as a student, so you will see him here with the 1 meter telescope instead. He then went on from Australia over to a Master of Science in the University of Victoria, British Columbia, and worked at the Atomic Energy of Canada, McGraw-Hill Observatory down in Tucson, Arizona, and then came over to York University, where he has been a member of the Department of Physics and Astronomy. He is a professor there, as some of you may know, tuning in. If you're a student, you might have taken some of his astronomy or physics classes. He is also the director of the Allan Carswell Astronomical Observatory, which means he is uniquely suited to answer the questions here tonight. So we were very lucky to have the two most qualified people to talk about the telescope here in the chat with us. Professor Delaney is a passionate science educator and delights in discussing the wonders of the universe of people with all ages, as you will, I'm sure, hear later tonight once we give him a chance to start answering these questions. Now, Professor Delaney is also the inaugural Allan I. Carswell Chair for Public Understanding of Astronomy, as well as holding many other different positions and, also accolades for teaching and science outreach throughout Canada. Now, Professor Delaney is just as happy behind the eyepiece as he is in front of an audience. Professor Delaney, it is really wonderful and great to have you here tonight. Thank you for joining us.
Thank you very much, Elena. I'm delighted to be here. 1 year, it's hard to believe. And I'm sure we'll talk about the reminiscence of the past year very shortly.
Indeed, we will. We'll actually just talk really quickly about the observatory and what we have going on at the observatory and the telescope, and then we'll go ahead and get into some questions. So the observatory, just in case you might be joining us for the first time tonight, the Allan I. Carswell Observatory does have a website. So if you are interested in more information about the observatory and would like to look us up, it is https://observatory.info.yorku.ca. We are on Twitter and Instagram at York Observatory, as well as on Facebook at York Observatory. And you can also find us on Facebook as Allan I. Carswell Observatory, just in case. If you have comments throughout today or just in general want to get in touch with us, feel free to email observe@yorku.ca. And the York Allan I. Carswell Observatory supports outreach and tours. As you can see here, there have been many over the years. We couldn't put a fraction of them into this slide, otherwise it would be too cluttered. But you can see some highlights from a few activities. Professor Delaney, you may notice yourself in the bottom image. If you look very closely, we've managed to get one picture of a slightly younger Professor Delaney inside the slides. Now, we also have, of course, research and different projects happening looking at galaxy characteristics, exoplanet transits, color magnitude diagrams, astrophotography, of course, variable stars, as will be mentioned a little bit later. We have a lot of moon imaging that we've been able to do with the 1 meter telescope, and we're looking forward to doing even more in the future, including, as we'll talk about later, spectroscopy. So that's a very, very fast little introduction to our observatory. And we'll go ahead and now just talk a little bit about the telescope. So the telescope is the star tonight. The telescope is our baby. Let's admit, it is a wonderful telescope. It works very, very well. It has an excellent pointing system, and its image quality is really quite amazing, especially when you consider that it is in fact right next to the football stadium and suffering some light pollution. So just a little bit about our 1 meter telescope. It does currently allow for gas and dust studies, structure and imaging, and in the future spectroscopy. We'll also be showing some additional images from our telescope later on as we go through the show tonight. That's just M1 you see down in the bottom corner there. So this telescope was brought in about almost exactly a year ago. So a year ago, 3 days, I suppose, is the way to say it. And this week we'll celebrate its anniversary. And again, we're just very lucky here to have the two people who really made it happen, Professor Delaney and Dr. Carswell. This telescope does have a dual azimuth focus ports, which allows us to simultaneously mount an imaging CCD and an eyepiece, or in the future, an imaging CCD and a spectrograph, which is incredibly valuable. Its capacity for outreach and research is really unrivaled with what I've seen at other universities, and it's actually the reason I myself moved to Canada. So we will talk more about the telescope and its advantages as we go through the show tonight. One thing that viewers who've looked through the telescope will note is the quality of the images. The better resolution is due to the great size of this telescope, 1 meter, the largest on-campus telescope, and the quality of the telescope itself. So that makes a huge difference. We'll expand on why this telescope is so good for our later uses in the sections with Sana and Gagan. All right, now we're going to move on here a little bit and ask some questions to Dr. Carswell. Now, Dr. Carswell in 1968 joined the faculty of York University, and we're just going to ask him a little bit about some of the things that happened at that time. Now, keep in mind, for those of you who don't know, Dr. Carswell was continuing his laser research as a professor of physics and working with high-powered lasers and, of course, LiDAR research for remote sensing and environmental diagnostics. So at this time, Dr. Carswell was founding or helping to found the Institute for Space and Terrestrial Science here in Canada. He was also the laboratory director and principal investigator over at the International Network for Detection of Stratospheric Change, or NDSC, if I'm saying that correctly. But the fun part about that is it's actually for LiDAR atmospheric observatories in Toronto and also in the Canadian Arctic. So Dr. Carswell, your first question is, you were in the faculty of York University in Toronto doing laser research as a professor of physics. During that time, did you ever get up to the telescopes while you were at York? And how long were you based at York?
Well, although I didn't have any direct involvement with the telescope facility, it certainly was always recognized as a very special and unique capability at the university. And one of the big traffic times was when the new students came in the fall. I was assigned a number of people that I served as an advisor for. And one of the things that they always enjoyed, and I enjoyed directing them, was to take them to the telescope and show them what it was involved and indicate how special a facility it was. And the other big use that I made of the telescope over the years, many years ago when I was somewhat younger, but I was also a Boy Scout leader. So I had every week a group of boys, usual, whatever the difficult age of whatever Boy Scouts are. And one of the big features was at least once a year, we would take the whole group up and tour the facilities and look through the telescope and learn a little bit about astronomy. So that was probably the biggest use. I was since I was working with lasers, my field was optical. And of course, astronomy has a very large optical component, especially that associated with the telescope. So it was something I was very close to, but the facility was always off to the side, and it was very active. And as Paul will be able to tell you, it was a leading capability at all Canadian universities at the time, and is still that way. So it was a very close association. And it was whenever we had visitors, I mean, at least every week, the physics department would have a seminar speaker come in and give a 1-hour talk. And they would often arrive for lunch. And one of the first things you would do after lunch was just give them a look at this telescope. So all these high profile visitors were shown, and the telescope was made use of to, again, to sort of boast or brag how great a place York was, and the special facilities we had.
That's wonderful. It is absolutely worth bragging rights, I think, especially now that we have the 1-meter telescope up there. All right, so we'll move on to your next question. So Dr. Carswell, we mentioned earlier, alluded to some of your activities on Mars, but just in case anyone didn't know, Dr. Carswell was co-investigator on the Mad Dog LiDAR instrument. So all of that talk about lasers and LiDAR earlier starts to pay off here. And the Mad Dog was accepted by NASA for inclusion in the Mars 2003 Mars lander mission. And although it was aborted, the LiDAR instruments continued as part of the NASA-supported, I believe it was Matador program. And Dr. Carswell's expertise with LiDAR led to the invitation from NASA to include Canadian LiDAR on Phoenix. So I actually have a Phoenix sticker on my laptop right now because I was following that mission very closely. But the NASA 2007 mission to Mars was very, very fun, and I highly recommend everyone to look it up. But Dr. Carswell was the co-investigator for Phoenix, and of course, with that development of the first LiDAR for Mars and studies of the Martian atmosphere, all kinds of amazing discoveries came out of that, including snowfall on Mars and lots of other fun things, including, as you can see in the slides here, there's 2 certificates. Dr. Carswell and his wife Helen and other members of the Phoenix mission team actually have their name engraved on a Silicon Mini DVD, which is in the spacecraft on the surface of Mars. So Dr. Carswell, your question is, your past in astronomy has really truly been out of this world, out on the planet Mars, in fact. Can you tell us a little bit more about this Mars mission?
Well, this Mars, there's of course been many missions to Mars, and I don't know what the statistics are now, but I think about 3/4 of the missions to Mars were not successful because it's a long way to go. Our flight was about 8 months, and it's not only the time that the mission takes, but when you think of the accuracy, not only to get to Mars, but also to find a specific spot on Mars. That always amazed me, the people who were looking after the guidance and so forth. And even as the space, well, ours was a lander, so it just sat down and sat in a given place. But the amazing thing was, even as it was landing, they wanted to have it lined up properly, north, south, and so forth. So from this distance of how many million miles away, the people who were looking after the operation of the spacecraft could do these things with amazing precision. I was involved as the PI, the principal investigator meteorology. We were coming with a Canadian supported and funded LiDAR. Now, LiDAR is light detection and ranging, similar to radar. Radar is radio detection and ranging. And so the LiDAR, as it operates, a radar sends out microwave pulses, and what they bounce off, you can see what's out there and get information back. The LiDAR does the same thing using pulsed laser radiation. And it's at the time when we started to work at York, this was one of the first LiDAR research activities anywhere. But we certainly, one of the things we accomplished, we discovered or became aware of the many great capabilities that LiDAR has. And in fact, LiDAR was at its infancy, and really even lasers, when they were first discovered, people were wondering what the heck would you do with this laser source. Well, nowadays, of course, LiDAR is one of the main technologies involved with self-driving cars. The car has to have things that look out. Some of them are pulse lasers, others are sophisticated imaging. But you look out as the car moves and you find out where everything is. And not only that, where it's moving and where it's going to be in a few minutes when you're going to be there. So all of these remote sensing techniques, which they're called, are now widely used for just an unimaginable array of activities. But our job on this Phoenix mission was to study the stratosphere of Mars. And our system, although it only had as much power, it was a pulse light source, that's what the LiDAR is, but the amount of energy was about equivalent to a 30-watt light bulb. So it wasn't very much. Yet with that system, making use of the very well collimated and short duration of the pulses, we were able to send LiDAR pulses up and as high as about 20 kilometers on the surface of Mars to get reflections back that would tell us what's going on in Mars throughout the whole atmosphere. So it really was a new capability which opened up many new investigations and a lot of information. I mean, the focus of the whole Phoenix mission was encompassed by the title, Follow the Water. They were pretty sure there was water on Mars, but that mission was aimed at discovering and, if you like, proving that there was water on Mars. And the mission was there. We were on the Mars surface for about 50 days or so, and did in fact show that there was water. And in fact, one of the advantages of we did see with the LiDAR, it showed that it snows on Mars, because there were certain times during the season that there would be actually snowflakes falling out of the sky. Now again, at Mars, the temperature is very, very low, and these snowflakes were not always made from frozen water. Many of them were made by frozen carbon dioxide. So to be able to freeze CO2 takes a very low temperature. And all of these things were part of the package. And of course, in addition, the Phoenix mission had a team of, it was 8 or 10 different teams of people looking at various aspects, because the spacecraft, in addition to pulsing our LiDAR up into the atmosphere, had diggers and scrapers and so forth to take samples of the surface material and analyze them and decide and find out exactly what was in them. So it really was a remarkable, and it was only scheduled, well, it was hoped to stay on the surface and get data for about 30 days. It actually ran for about 50. So it was an excellent acquisition of information about Mars.
Absolutely. And it's really a fantastic mission. It's one of my personal favorite Mars missions. So I'm very, very pleased we could discuss it with you today here. Now, we just have two more questions for Dr. Carswell from Gianluigi. Gianluigi, take it away.
Absolutely. So, Dr. Carswell, in 1974, along with your wife, Helen, you founded the Optech Incorporated as a spin-off from your university research to enable an increased emphasis on the more practical applications of the LiDAR system. Now, Optech developed LiDAR systems and application using advanced electro-optical technology to become the world leader in the provision of lasers for airborne surveying, 3D imaging, atmospheric measurement, which is a process control applications for and space systems. Now, in 2015, Optech was purchased by Teledyne Technologies Incorporated, but Dr. Carswell actually continue on other endeavors as he is the founder and president of the Carswell Family Foundation, supporting community philanthropic work in education and healthcare. So my question for you, Dr. Carswell, is with the Allan Carswell Charitable Foundation, how did you decide to help build the 1 meter telescope for York?
Well, that was actually quite easy because when we sold Optech to Teledyne, and of course, much of the work that started out in Optech is still going on in Teledyne around the world because Teledyne is a huge corporation with many different aspects. But with some of the funds that we acquired from that, we decided to set up a foundation to support various activities, and the areas that we chose were education and healthcare, because certainly there's nothing more important than education, certainly for the young folks, but I always like to make sure that the young ones understand that not everything ends when you graduate. The whole aim is to have lifelong education. You should be learning all the time. But education was one of our focal points, and the other was healthcare, because there are many things that can be done. And nowadays, you know, there's much that can be done with lasers, certainly in terms of skin blemish removals and things. But anyway, but on the other hand, since we were a charitable organization, we will accept proposals. And that was how we got involved with the telescope. The clever people at York realized that York had a very special capability. That is this twin dome observatory facility. I don't think there's another thing like it, certainly in Canada. But to have these two domes, quite large, quite capable, capacious, they approached the Carswell Foundation and said, you know, we could fit a 1 meter system in there, and we'd like to have it. So as I say, as far as deciding that was just easy, especially when they said, look, for every dollar that you'll give us from the foundation, we'll match it with a dollar that we come from various other inputs around York. And so again, we got double our money's worth, and York did it, and they now have this state-of-the-art facility to go with the state-of-the-art building, if you like. The telescope is now really the guts of the building and the value that you're getting out of this special twin dome facility. And it's great for education as well.
Yeah, I absolutely totally agree. I mean, as an international student, one of the reasons why I came all the way here was for the observatory. And I think the 1 meter is just the gem that makes me feel so proud of being at York and the worth of coming all the way to have this incredible opportunity education-wise. So yeah, on my next question. So one of the largest projects currently is the ongoing differential photometry of SX Phoenix variable stars since 1995, running on the 60 centimeters. Now, the 1 meter is installed, and we have improved on pointing as well as the light gathering capacity. The opening night of the 1 meter telescope, and we were so happy that behind the eyepiece, we had Professor Delaney, and also we had the amazing opportunity to have you also there, and other several people from York, as well as the members. So from the opening night of the 1 meter, what was the most exciting part that you personally remember, and what are your impressions and research hopes for the 1 meter?
Well, I think as far as the specific use of the telescope, Paul is probably the better one to respond, because as I say, the reason that we got involved, that the Carswell Foundation got involved, was we were asked to provide this rather special facility. All the special attributes and now the actual demonstration of the special capabilities, I think that's the thing that Paul could probably respond to quite nicely.
And I certainly will, but perhaps just the other part of the question, Alan, what do you remember from the opening night? What was your sort of feeling about that night last September?
Well, it was, I guess, one of the first things, especially being used to what it was used to be like, was just how big that telescope is. And I think most of the students that arrived at just realized what it is. And but no, there was a lot of interesting work. And of course, that first night, I'm sure was, again, Paul can comment, but it was very much making sure things were working and just seeing what you could do and noticing what was much better and much different than previously. So it was certainly very special.
That's great. And yes, I totally agree. I think the 1 meter is humongous. And I can totally agree that everybody agrees that ever been at the observatory, it's much harder now to put the caps on the secondary mirror to protect it from the dust. It's a much more complicated procedure compared to the 40 centimeters. But we struggle with a lot of passion and devotion for the 1 meters, absolutely. So thank you so much, Dr. Carswell, for your answers. And now we're gonna move on to Professor Delaney, and Sana is gonna go with the first set of questions. So I'll give it to you, Sana.
You're welcome.
Thank you, Gianluigi, and thank you, Dr. Carswell, for answering all of our questions. So Professor Delaney, the first thing that I wanted to ask you about is kind of how we got the telescope. So there was a couple years between the announcement of us getting the 1 meter telescope and then us actually receiving it on August 16th. And during this time, the observatory underwent massive changes to be able to accommodate this telescope. So I wanted to ask you about kind of what was some of the planning and preparation that had to be done leading up to this installation?
It was time that was wonderfully spent, even though it was very disruptive to our operations, but well worth it. Yes, it was September of 2017 when the official announcement came that we had the funding. And of course, the very first thing that I had to do was decide, what telescope were we going to buy? Having the money in hand was one thing, but deciding what telescope would fit inside the domes, what would complement the various course activities that we were engaged in, the various outreach activities, all of the logistics, if you will, of getting a telescope and shoehorning it inside an existing dome and deciding what aspects of the dome needed to change to accommodate that. That was now the task at hand. And that went ahead for basically the majority of 2017. We started actually a little bit before the official announcement in June, and I finally came to the conclusion that the best instrument to buy, the best telescope to buy, was from PlaneWave. But now deciding that, of course, you've got to have quotes, and so we went out in the bidding process and went through all of the appropriate checks and balances to make sure that we were getting good value for our money, that they were going to be able to deliver the product in a timeline that worked for us. And that basically took us through to the end of 2017. We had hoped that we would be able to install the telescope by December of 2018. Let me make sure I've got my timelines right. Yes, 2018. And as we were moving towards that timeline, not surprisingly, because PlaneWave has a very large and well-deserved, well-earned international reputation, they were producing 1 meter class telescopes and smaller telescopes at a phenomenal rate. And the timeline for getting our telescope to us really had to be before the depths of winter set in. I mean, I know as Canadians we're able to handle the winter, but installing a telescope in a blizzard really wasn't going to be any fun. So we said we have to see this telescope on our loading dock in December. And if we can't, then we need to push that date into the following summer. And it became fairly apparent that PlaneWave was going to struggle to get it to us in that timeline, and we certainly did not want to rush the installation. December weather here, we were also knee-deep in exams. So basically, we made the decision in and around November, December of 2018 that instead of rushing the project into existence, we were going to push it off until May. And so we made that decision, got past the winter. PlaneWave looked at their timelines. We were looking at the various mirrors that were rolling off their assembly line. And we eventually concluded, okay, the best timeline that works for all of us is going to be an installation in August of 2019. So it was a little bit later than we had originally wanted, but as I said, we were not about to put a telescope install in the depths of the Canadian winter, so we didn't.
Yeah, it was well worth the wait considering how amazing that telescope is.
Absolutely, and you were there, of course, in August of last year. We couldn't have asked for a better day. It dawned crisp and clean and clear, and that night, of course, it was equally clear of first light at 9 o'clock. So yeah, it was a special day, August 16th of 2019. Hats off to PlaneWave, by the way. They were ever so professional in their install that day. It was just fabulous to watch them at work.
Absolutely. So that's actually the perfect thing to end that question off with, and it leads in very well to this one. So because I wanted to ask you about the installation and the first light. And like you mentioned, we ended up observing that same night that the telescope was installed, which we were incredibly lucky to be able to do. Some of the pictures that we got during first light are actually shown on the screen there. And one amazing thing about these images is that they really reveal so much detail, particularly, I think, in my opinion, the Dumbbell Nebula on the top left, despite these being just single CCD images through one filter. So for our listeners who don't know, when you image with CCD cameras like we have at the observatory, you initially get black and white images just like are shown on the screen. And then if you want to get these multicolor astronomical images, you have to take pictures using several different filters, usually red, green, and blue, which is what we use. And then you combine them into single color images. You take very long exposures, so some pictures can be made up of images over 30 minutes, a couple hours, just to get one single image to reveal as much detail as possible. But this is kind of a testament to how amazing this telescope is that these are just single images through one filter, and you can see so much through them. So the thing that I wanted to ask you, Professor Delaney, is the installation took all day. It started at around 9 a.m. and then it finished later that day at around 9 p.m. after which we were observing. And I wanted to ask, what was the installation process like, and what was first light like, being able to see the pictures from the telescope for the very first time?
Well, the installation process was memorable from my point of view, most notably because we were lifting the various elements of the telescope from ground level up to the observatory deck, which was, give or take a bit, 4 stories in the air. So there was this very large crane that was parked there, and it was picking up the various elements, the boxes and so on, and the hardware of the telescope. And then you would watch it go up and up and up and up, and okay, give or take a bit, 15, 20 meters in the air. And you would see it swinging on the cables. And oh yeah, it was definitely a little nerve-wracking, especially when they raised the 1 meter mirror from ground level. So yeah, the PlaneWave guys, they knew exactly what they were doing. Cool as cucumbers. It was just, us physicists and astronomers sitting on the ground that were worrying about it more than anything else. But the process, as you said, unfolded over about 8-9 hours. And it really is a turnkey type operation. They moved up item number 1 and item number 2 and item number 3. And, it just bolted together ever so sweetly, ever so smoothly. One thing that I should add, one big change that took place in the dome over the ensuing year and a half from when we received the funding and the decision to buy the PlaneWave telescope, was to install a brand new pier in the dome to hold the much larger telescope. The dome used to be, of course, the home of our 40-centimeter telescope, lightweight device by comparison. And so we had to demolish the original concrete pier and put a brand new pier in. And this is all 4 stories up in the air. So you put it all together. It was quite the engineering exercise. The teams from York did very, very good work to get us to this point. And then PlaneWave assembled the telescope, lock, stock, and barrel in the dome. They finished off, I guess, around about 6-7 o'clock, quick bite to eat, and then it was first light. And as the images on the screen testify, it was evident from the outset that this was a magnificent telescope. We hadn't fully collimated it at this point in time. This was literally out of the box into the dome and onto the pier, pointed at something in the night sky, and all of a sudden the field of view, the crispness of the field of view, the quality of the imaging, all with a relatively uncollimated telescope, it just told us that we had really a magnificent instrument at our disposal. And so that Friday night, and you were there, Sana, watching the images come in, and then the guys go to work. It was just fabulous.
Yes, absolutely. It's quite an amazing telescope, and I'm glad to have been there for first light as well. All right, so now passing it off to Gagan, she'll be asking you about some of the more technical aspects of the telescope.
Thank you, Sana, and hello, Professor Delaney and Dr. Carswell. As Sana said, my questions tonight are about the tech the telescope offers. Given the telescope's increased mirror size and light collecting ability, we know it's a much more powerful telescope than other telescopes on campus. What were some of the specific features of the 1 meter that led us to choose this specific design, and what other technological advantages does it have compared to the 40 centimeter and 60 centimeter telescopes?
Well, the biggest thing, of course, is the light gathering capability. This is a 1 meter class telescope. Our 60 centimeter telescope, the workhorse since 1968, fine telescope, rest assured, but the 1 meter picks up 3 times the light that the 60 centimeter does. So that makes the fainter objects that we are able to observe now just stand out so much better. So increased light gathering power was really important to us. This is a much faster telescope. This is an f6. Our 60 centimeter is an f13. So again, immediately we've got a huge improvement in our field of view, which means extended objects are much easier to capture in their entirety. And from a student's perspective, trying to find those objects, a larger field of view allows them the capability to be a little off in their pointing and still be able to identify the field very successfully. Now, that said, this telescope has no idea how to not point perfectly. That was the other aspect of it. Technologically speaking, this telescope has absolute encoders in contrast to our 60 centimeter, which is a relative encoder system. The absolute encoders basically means that when we turn this telescope on, it immediately knows exactly where it is. And when we say, go to fill in the blank, it's there. The object appears literally in the center of our field of view. So that is a huge, huge improvement for our public viewing capability. Now we can spend much less time going between objects and figuring out where those objects are. Now we go to those objects and everybody has their Galileo moments at the eyepiece. So improved efficiency from the public's perspective and being able to enjoy the night sky. And from our students' perspective, they're spending much more time analyzing their data than collecting their data. So those were just some of the attributes that really, really excited us with the plane wave 1 meter telescope.
Thank you. And so far, we've talked about how the 1 meter came to find a home at York and the technical aspects of the 1 meter and the advantages it has over our older telescopes. But what improvements do we have or hope to see in the future with respect to research, outreach, and education?
I think it was Elena who mentioned earlier on that this telescope has two what we call dual Naismith focusing ports. Unlike most telescopes where your eyepiece is the business end of the telescope and you can only have an eyepiece or an instrument on, you can't have 2 things on there simultaneously. This telescope with a flip mirror just in front of the primary mirror allows us to go between 2 ports in literally a matter of seconds, meaning that we can mount our photometer on one side, an eyepiece on the other side, or a spectrograph. This immediately, again, improves our efficiency for the public as well as for our students. You can give them the Galileo moment. Anybody can have a look through the eyepiece. But then when you've got a CCD, a charge-coupled device of the quality we have put on this telescope, it means that you move from what your eye can see, a nice, crisp, black and white image, shades of gray. You flip over to the CCD, and now the power of the CCD, a 15, 20, 30-second exposure, all of a sudden, the amount of detail you're able to see, the excitement you generate with the public when you can see the belts of Jupiter, the red spot, and so on. It's tangible, the improvement that the CCD offers, and people can see it immediately. And so for the Galileo moments, for the students who are sort of galaxy hunting, and of course for our research capabilities, the ability to be able to reach deeper into the universe with greater clarity, that's the data set that now the students are able to work upon. And again, you can see their level of enjoyment go up. The 60 centimeter does a nice job, don't get me wrong. But when you're able to have a cleaner data set, a deeper data set, then the possibility for finding out more about your target, that excites the students. And so this telescope's improved capabilities, and particularly, as I say, the dual Naismith ports, so that we can go between instruments or go back to the eye if needed, that just improves the quality of the observation, be it with a member of the public or be it with any of our student observers.
Yeah, absolutely. The dual Naismith ports are one of my favorite parts of the telescope, actually, because before, when we had the 40 centimeter up in the dome, it took a while to take the CCD off, put the eyepiece back on, and if we wanted to go back to imaging, it would be a long process to reinstall the CCD.
And fraught with danger too. I mean, as careful as you are, it's a darkened environment. If it's the depths of winter, the moment you start handling instruments and small little screws and so, it's just a recipe for challenge, shall we say. We've never dropped anything, and that's great. But now, once you've got everything on this telescope, if it's improved pointing capability and the dual ports there, it just is a dream to work with.
Yeah, definitely much easier. As for research at the observatory, we are also about to install a spectrograph soon. And so far, the research with the 1 meter includes multiband imaging, photometric observations, and since we're welcoming spectroscopy soon, what observations, including targets in the solar system or Milky Way and beyond, are you looking forward to observing? And do you have any thoughts on the future of science at the observatory?
Well, of course, one of the other things that we've been doing in this past year is a little bit of exoplanetary observation. This telescope allows for much greater precision at watching exoplanets pass in front of their parent stars, and therefore, of course, generate the transit method to be able to identify orbital parameters of exoplanets. That will increase in its activity. It's a photometric aspect of the activity, but it is one that, again, the students are able to engage in very, very easily. Spectroscopy is going to allow us the opportunity to dig a little bit deeper into a variety of differing astrophysical phenomena, looking at stellar spectra, looking at the way the spectrum of a star changes as a consequence of its evolution, perhaps associated with the not the give and take, the to and fro motion of stars, what we refer to as the radial velocity, to be able to analyze the composition of these objects and to watch those changes in near to real time. That will be a new aspect of observation at the observatory. And in large measure, Elena Hyde will be looking after those projects. So something we weren't able to do with the 60 centimeter telescope, something that we are looking forward to being able to do with a variety of resolving capabilities on the 1 meter telescope. So yes, spectroscopy will be the new arrow in our quiver, shall we say, with respect to primarily research, but it will also be able to give us the opportunity to explain to our guests. One of the questions that is often asked is, how do we know that the star is made up of A, B, and C, hydrogen, helium, and what have you? How is it that we're able to look at clouds in space, nebulae, and determine their compositions? It's something which is not necessarily obvious to our guests. And so being able to produce our own spectra and be able to explain what it is those spectra are telling us, that will be a huge asset as far as our public outreach is concerned.
For sure, I'm definitely looking forward to it.
I'll just hop in here for a second and say this might be a handy time to just check over in chat and see if we have any extra questions from the audience. In the meantime, Dr. Carswell, do you have any thoughts about the future of the 1 meter telescope that you would like to add?
Well, I think it's, as with all research activities, I mean, there is the two aspects for the telescope capability. The first is the education, to show everybody, even in the general public, what astronomy is all about, how interesting it is, and probably attract some of them to follow along. But also on the more research side, no one knows what's around the corner. Research is just full of surprises. So the fact that you have the capability now to look in much higher detail in many aspects of what you see or what's going on out there, or the light that's coming in, then as time marches on, you'll suddenly see something. Well, how come this is happening? Why do we see this little blip here in the spectrum or in whatever? And that's when you get some of your grad students, for example, onto that, and they may spend their whole career trying to figure out what that little blip or change. And that's how adventure is, or research is advanced. It's looking at things that you think something is unusual. Let's find out what's so unusual and what's going on, because that's what's driven most of the advance of science and technology over the years, just seeing things you didn't understand and then trying to figure them out. So this telescope gives a lot of capabilities, both in its spectral coverage and its pointing capability and the light gathering abilities and so forth. So it's who's going to be able to tell exactly what will be discovered, but you never know. But you now have more capabilities to investigate and possibly discover some new things.
Absolutely, and it's all about the what's that kind of moments. Now we do have a few questions coming in from chat. We have a quick question about the sort of objects through the 1 meter. Now this one's for Professor Delaney from Matteo Stadi. What object created the most excitement for you when you saw it through the 1 meter?
That's a good question. One of my favorite objects to look at in the night sky is always the planet Jupiter. Jupiter always has wonderful things happening. And as you can imagine, the 1 meter telescope generates a great deal of detail on the cloud tops. So that's very exciting. But perhaps the object which has given me the most thrill, shall I say, from the point of view of detail, was actually one of the first light images, the Bubble Nebula. Looking at the very delicate shades of gray, the cloud, the nebulosity that swirls in these objects, and what the 1 meter is able to show under good seeing conditions. It literally took my breath away when I saw the Bubble Nebula. There have been many objects that we've looked at over the year, the past year. You know, the moon, you might think that the moon is a boring object. Oh, looking at it through the 1 meter telescope, it's hardly boring. It's also hardly dull. It's really bright. So I guess in that order, Jupiter, the Bubble Nebula, and the moon, those objects really just blew me away in terms of the quality of the imaging and what we could actually see.
And I believe that Dr. Carswell, you went up to the telescope and were able to look at a couple things after it was installed, correct?
I beg your pardon?
Were you able to look at some objects through the telescope
Oh, yes,
after it was installed?
I had a few peeks, but not being a research specialist or an astronomical specialist. I'm looking at them much the same way that an average person would, just of interesting things and trying to understand, and then requiring people like specialists like Paul to tell me what's going on so I understand. And of course, that's with any research field. You so very quickly get into the detail that you have to rely on the experts, and of course, with this being located in the university, some of the best experts, of course, are the students, because they dig in and they're always asking questions and so forth.
Yeah, well, no, it's one of the things that is great about this telescope is you don't have to be an expert in order to enjoy the views. Now we're just finishing up. We have a little bit of an outro left, but I think speaking of views, Professor Delaney, you are at the 1 meter right now, correct?
I am indeed. I'm in the control room of the 1 meter. And if you will permit me to just take off the video, I will move across to the planet Jupiter.
All right, excellent. Go ahead and turn off your video. And for everyone in the live stream, please excuse the short break in our video here. We are going to switch over to the telescope. And we're just turning on the telescope connection now over onto YouTube. So please excuse our excuse the brief interruption here. We will be back with programming in 2 shakes of a lamb's tail. Here we go, and we are very happy to be able to share with you right now the view from the 1-meter telescope. As you can see, we have some interesting things happening here. Now, I believe we're pointed at something bright. Is that correct?
Okay, so I will just bring audio back on. We have just moved across to Jupiter. I have not fine-tuned the intensity, the exposure at this point in time, but you can see 2 Galilean satellites, 3 Galilean satellites at this point in time. And if you will permit me, we'll play with the CCD imaging here and should be able to bring out a little bit of the detail associated with the belts. Just give me a moment here.
Oh, lovely.
All right, as I say, I have not fine-tuned the focus. That's a little bit of a fiddly process. But as you can see, that same image where moments ago we could see the Galilean satellites, now you're beginning to see some of the belts and the zones, the cloud tops of Jupiter. And I suspect that this over here is probably the Great Red Spot. If I sharpen the image a little bit, I'm sure we could get a little bit better. But as I said, it gets a little fiddly, so I'm not going to take up a lot of time on air. But you can see how easy that was. I mean, literally, when we were talking with Allan moments ago, we were literally just looking at a random star just to make sure that the telescope's pointing was okay. I asked the telescope to go find Jupiter, and it took, in the vicinity of 6 seconds to get there. It moves silently, it moves quickly, and it moves efficiently. And before you knew it, we were set on the planet Jupiter. And so now you can begin to enjoy some of the sights of the solar system.
Excellent. And we are seeing, this is live images from the telescope right now. So if you are in our live chat, you are seeing Jupiter as it looked however many minutes ago the light left Jupiter and started traveling towards Earth.
Yeah, probably about 20 minutes or so, 25 minutes.
20 something. But yes, we have a little conversation in chat. How many planets have been able to be imaged with the 1-meter telescope? Now, I don't believe anyone has successfully gotten Pluto, although I believe one of our students, Ariella, has probably tried. But
actually, I think that I did successfully do that. Sana, you may be able to chime in here, but were you with Ariella and successfully imaged Pluto?
No, we haven't done Pluto yet. It is on the list, and she does definitely want to get pictures of it, but we just haven't really had the chance yet with when it was up and when she was around and everything. So not yet, but hopefully soon.
Okay. But all other planets have been imaged, and we've done that with a variety of telescopes. Tell you what, while we're chatting here, just seeing we've got the telescope nicely aligned, let's see if we can pull in Saturn, because it's in the same area at this moment in time.
Yes, and as you can see, there are some movements happening on the screen, showing various different things moving around. That is actually the telescope. I think I can go over there now. Yes, just to show everyone the telescope control screen. I'll have to switch back shortly because we do have, of course, Zoom and YouTube running on multiple screens.
Yeah, I was going to say that was an interesting effect there. All right, moving over to Saturn.
the telescope is in motion, and then once it's finished moving, we can take a new image of the planet Saturn, and that will then go through the CCD. So right now we are using the CCD half of that dual Naismith function. So we're not able to show you, through the eyepiece because there's currently no camera through the eyepiece side, but you're viewing what the CCD views, which is, we could take then multiple filters and make colorized images from this, but it's a little bit of a different view than what you get through the eyepiece.
Okay, sorry, hang on. That's not what we want.
0.2 seconds.
Well, it's pretty bright out there at the moment.
Yes, and this is a good reminder, actually. We have been the last few episodes, we have been taking images in the 7:30 to 8:30 window live from the telescope, which is actually fully bright sunlight here in Toronto. So our 1 meter telescope is battling the sun to bring us these images. The sun is setting in Toronto now, so we're getting better and better image qualities, but we won't be able to stay up all night on this live stream, unfortunately. We will all have to stop and go to bed at some point.
We're just adjusting the position of the shutter at the moment. So give us about another 30 seconds and we'll see whether or not we can pull in Saturn into our field here.
So a few questions in chat. What is the exposure time that we're using? I believe we're up at 1 second exposure time.
We are at the moment at 1 second. Okay, which obviously we're still a little overexposed with. So let's try and adjust that down a little bit. These planets are bright, 1 meter collecting area and so on.
Yes, and everyone watching is now getting a real-to-life experience of observing, trying to pick the correct exposure time, trying to pick the correct object. Obviously, we were talking about being able to image all of the planets earlier. You do have to actually have it planned out because different times of the year will have different rise and set times for different objects. So it can be quite difficult to find an object if you're not able to get it to line up correctly, or especially if you're a student, as most of our crew is,
okay,
with classes.
Still overexposed, I'm afraid. Okay, let me just try one more thing here to try and get it into the right arena for us. Okay.
So choosing a less sensitive filter here to see
see
if that'll bring it in for us. And we're down to an attempted 0.2 seconds.
I'm getting closer, but I'm not sure I'm going to be close enough.
Well, it's an oblong, so there you go. That's it. And we have Saturn live from the 1 meter telescope.
A little bit out of focus, but as I've said, to fine tune the focus is a little bit of a fiddly process, well worth doing, and all of our students do go through that motion, but doing that live on air is a little bit tedious. And of course, it doesn't necessarily take a few minutes. It can sometimes take 10 minutes to get it nice and sharp. But obviously, as you say, it's elongated, the ring system. You can see the planet sort of immersed between the ring system, the dark edges on either side of the planet. You can understand why Galileo called this a planet with ears back in 1610.
Absolutely, and several compliments coming in from chat. Beautiful images, and of course, I'd just like to put this on the video. Comments on the interface, super slick.
Oh yeah, really nice.
I have to absolutely agree. All right, everyone. It is a little bit past our usual ending time, but I will go ahead and open it up for any questions, comments, or general chit chat. Let's just see. I will go over and check the chat for any last questions. Allan and Paul, feel free to chit chat.
So I'm just going to simply say to Allan that, thank you very much, mate. I mean, this has been a wonderful gift to the students, and I freely admit that I've loved using it, but I've even more enjoyed seeing the eyes light up for our younger students, particularly as they've come in and had a look through the telescope for the first time. You can feel their awe as they stand in front of the telescope, but when they put their eye to the eyepiece and they see, you know, the moon or one of the planets there, that makes it all worthwhile.
It's something that everyone is interested in, no question. And especially if you get out into the countryside where there's no lights to interfere, it's the universe is just amazing.
It is.
It makes everyone, even the dullest person, think deep thoughts. What's out there, and why am I here, and why is everything this shape and size? So it really is stimulating to one's imagination and thought processes, dealing directly with the universe. There's just so much of it, eh?
And it keeps getting bigger. It's grown just in the time we've had our conversation.
Oh, that's right. It's
No doubt, no doubt. Our first year students this past winter had the opportunity to take home their own images of the moon. We were taking images with them present, talking to them about, you know, the telescope, astronomy in general, but the moon was the focus, and we would take a series of images. Sana would then clean them up for us, make them really nice and crisp and sharp, and the students would then take those home with them. Yes, they had to do an assignment on it, but they had their own images. And several of them wrote back to me after the class saying that, A, they thought it was the highlight of the course, doing the lunar observing, and several of them made screensavers out of their images of the moon. So it really hit a receptive chord with our first year class, and that was just the moon.
Excellent. All right, well, I'm going to go ahead and grab the screen away from you here.
That's fine.
And bring us back. So please, again, excuse the small interruption here. And we will go back. On our way back. Sorry about the slightly longer transfer to get back to a shared screen here. And we did just get one last little question about the software. How, I believe it was, how long or how much training does it take to use the software? And this is perhaps a question for our students, because if you're learning this software for the first time, we actually have several different pieces of software running all at once. Most of what we showed everyone was, I believe, the sky, correct, Paul?
Yes, sorry, I was muted.
Yes, so we had the sky as well as the plane wave software, and we also have a few other extra softwares that we use for various different things. So you wouldn't need to necessarily learn all of these, but if you just wanted to master, say, the plane wave control software and the sky, how long would you generally allocate that for students?
Well, let's ask Sana and or Gagan, because they've both used the system, particularly Sana. How long before you felt comfortable driving the telescope yourselves, ladies?
For me, it wasn't really long at all. It's a very, I guess, straightforward software to learn, especially because we don't have to align it. But it was for me a lot easier than especially the 60 centimeter. It's really a lot of fun to use. Very easy especially compared to other telescopes that I've used.
For sure, same with me. I believe the plane wave software to drive the telescope only took only about a day of observing to get into the swing of things. But for astrophotography, that software takes a little bit longer, probably about a couple days of observing or so.
Well, actually, you do raise a very good point, Gagan. You know, to collect the data with the sky is one thing. To process the data and create amazing images, that's a whole other ball of wax. And Sana in particular has mastered yet another program called Pix Insight, which really does wonders as far as teasing out the details of objects. But Pix Insight is not for the faint of heart. That is a bit of a challenging program. And Sana, I think it'd be fair to say that you've spent many hours with it, but you're still learning tricks of the trade.
Oh yeah, yeah. I actually have used another student's Richard Block. He made a lot of really, really good Pix Insight tutorials, and I learned the basics from those. But it seems like Pix Insight has a little something for everything. So there's always more to be learned about the Pix Insight software and the amazing things that it can do.
Absolutely. And if you really want to get complicated, you can always go over and start learning PyRaf and IRAF. But we won't saddle anyone with that, because I've been doing IRAF for a long time. Still not a master of that one. It's quite a challenging set of programs and routines, shall we say. Now we'll just go ahead and end off here with a little last message coming in from chat. We do have a nice message I thought would be fun to read out here. A former student and junior researcher and Astro Club member is giving a huge thanks to Professor Carswell and Delaney from their whole family. Kids 11 and 13 are watching this right now. So thanks to the observatory team for a great session. So I thought that was a very nice nice note. We have a whole family watching tonight. Any last messages, Dr. Carswell, Professor Delaney?
Well, I think it's just great the way this is enhance the interaction with the people at large. I mean, the fact that you've got a whole family, you can ask them what they learned or what their interest is. But no, it's impressive in many different aspects what these sort of facilities can do.
Agreed, and certainly pandemic notwithstanding, we are going to get ourselves, we've been engaged in the virtual work of passing on astronomy on Monday and Wednesday nights, and we've got plans to expand that come the fall. So yes, just the beginning of more ways for us to share our love and our passion for astronomy, as well as the capabilities of this telescope. So stay tuned, everybody. There's more to come, but not tonight.
Actually, and next week we have a whole other episode.
Right.
We'd just like to put a little advertisement here. If you enjoyed this program, please make sure to tune in next week for an exciting astronomy Jeopardy game, which you can play along to. And I think that is actually an excellent time to hand off back to Gagan for our final outro. And thanks so much to Dr. Carswell, Professor Delaney for joining in. Thanks to everyone who tuned in and asked wonderful questions. And yes, thanks to all of our crew for a wonderful show. So Gagan, take it away.
Right. Thanks for joining us, everybody, especially Professor Delaney and Dr. Carswell. This concludes our presentation for tonight. Thank you, everybody, for tuning in. You've been listening to the Allan Carswell Observatory's weekly TeleTube broadcast, the Astronomy and Astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana, Gianluigi, and myself, Gagan, along with Dr. Elena Hyde, Professor Paul Delaney, and Dr. Allan Carswell. You can always connect with us on Twitter and Instagram with the handle @York Observatory, and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.